now trying to solve some example based on triangle law. So in this example, the question is that find resultant of the two forces, that is F1 and the F2, using triangle law. So here F1 is equal to 20 Newton, that is act with this axis with angle of 30 degree, and F2 is equal to 50 Newton, that acts with this axis with the angle of 20 degree. Now the question is to find out the resultant of these two forces. So let us try to solve that. So for the solution that we solve by some equations, and those equations are basically known as a cosine rule and the sine rule equations. So here we try to draw a triangle, but that triangle will follow the rules that we already seen in the previous lecture. So considering the force F1 and F2, so we are just draw a one closed triangle. So let us take force F1 with its proper magnitude as well as maintaining the direction. So first of all, we just draw a axis which is similar to that. After that, we require to follow a pattern of that force F1, and that consists with a proper magnitude and the direction. So this is our force F1 in this particular direction. So we write down here F1 is equal to 20 Newton. And here we consider point A, and at the end this is point B. Now by following the principle of triangle law, we just start our second force, that is with the head of this first force, maintaining the particular direction as well as the magnitude of that force. So that is in this particular direction, and the magnitude is somewhat higher than the force F1. So let us draw a proper line with the proper length, and we just write down this is our F2 is equal to 50 Newton. Now we know that this is axis and both the line. So while drawing this line, we have to maintain theta is equal to 30 degree with the horizontal, and here we require to maintain 20 degree angle with the vertical, that is given in this case, right? Now a closing side that we take, or that we start in a reverse order, and we try to just match with the head of the second force, and that will coincide at point C, right? And you can also graphically measure this angle. Now in this we consider this is as a theta, and here it is 20 degree. So the angle that will make with this, that is required to find out now. So if we consider this third and the closing line that as a resultant, now the angle that is produced at this location, that is required to find out. Now here if you see that And for simplicity, if we draw a horizontal line at point B, so at B this is a 20-degree angle, okay, and this one is the 30-degree angle. So the remaining angle, if we thought of that, so this angle would be, so if we extend this line, right, so if this is 30, maybe this is also 30. Same way if I draw here, so you can understand very easily. If I extend this line and here is the 30-degree, so definitely this one is also a 30-degree, and this line both are perpendicular, so this will be a 90 minus 30, so this will make a 60-degree. Okay, so this angle is a 60-degree angle. Now this angle is required to find out. Now if we see that the angle at C will be nothing but the total summation of the angle of the triangle, that would be 180, that we know very well. So if we want to write down that the angle at point C, that would be 180 is the total summation of all the angles. So 180-degree minus 60, then plus 20 plus 30 plus theta. So that equals to, we can write down easily, 70-degree minus theta. So this angle is 70-degree minus theta. Right? Now still we have some unknowns in terms of some resultant and the theta, but you can find out that theta very easily using that sine rule. So first of all, we are trying to find out the value of the resultant. So here, using cosine rule, we can write down, or we can use that cosine rule equation. So I can write down here a simple equation that you remember, r square is equal to that f1 square plus f2 square plus 2f1 f2 cos theta, or you can write down cos beta, right? So now by modifying this equation, we can write down cos beta is equal to f1 square plus f2 square minus r square, and that whole divided by 2f1 f2. Okay, now we put the value of that all forces into this equation. So now what is b? Now b is nothing but some theta value. Now considering the beta that equals to the corresponding angle of r, that is 80, so cos 80 is equal to f1 square, that means 20 square, plus f2 square, that is 50 square, minus r square, divided by 2 into f1, that is let us take f2 into f1. Okay, so the answer would be, if you sort out this, 50.52 Newton. This is our first answer. Now if we try to find out direction of that resultant, or we can say the theta value. So that theta value is find out using a sine rule. So I can write here using sine rule. We just put force F1 and the corresponding angle to that F1, that is 70 minus theta. So this is sine 70 minus theta is equal to R, and the corresponding angle is 80. So R divided by sine 80, right? Now if you put F1 is equal to the load, that is 20 Newton, and the R is the unknown. So again write down 20 divided by sine 70 minus theta is equal to R divided by sine 80. So if we solve that, we have a answer of the theta, and that theta would be 47.05 degree, and that theta is with horizontal in this particular direction. So this is our answer number 2, that represent the theta of that particular resultant. Now resultant can be obtained by drawing force 2 as a first force as well as force 1 as a second force. So for that, if we prepare a new figure, so that is turn out to be like this. So let us draw a force 2 in its particular direction. So here we start with a force 2 in this particular direction, that is our F2, right, maintaining the corresponding angle, and that angle would be a here, that is 20 degree. Again in the second step we draw another force, that is force F1, maintaining the proper angle here and the magnitude of that particular force. So this is our F1, and if you see that, that will make a 30 degree with the horizontal, and then we require to join that in reverse order with a third side of that triangle, that is R. So now here this is a theta. If you count that, this is again a 70 minus theta, and this angle that would be a 80. Again here we can take a 70 degree, and this is 30 degree, right? So total is a 180 degree, and this angle that would be a 30 plus theta. Okay, if we sort out the geometry perfectly, you can find out that very easily. Again, this way you can apply a cosine rule and the sine rule, so the answer would be the same in this methodology also. Now here in this example, we require to find out a component FA and FB of 100 Newton force. So here this is FA component and this is FB component, and this one is the 100 Newton force. FB and 100 Newton force, that makes an angle of 100 degree, and FA component and 100 Newton force, that will make a 30 degree angle. Now using that triangle law, we require to find out the components of that 100 Newton in terms of FA and FB. So let us try to solve this example using triangle law. Now for the solution of that, again we require to draw one figure, and that is using a proper scale, maintaining the magnitude and the direction of the forces. So first of all, we require to draw this FB force. So for that FB force, from the tip of that FA, okay, so instead of that, that is also very easy to draw FA force. So we have some line of action, so with respect to that we can draw another force in this triangle. So starting with that FA force, we just plot FA with respect to its particular direction. So here is the force FA, and if we extend that line in this particular direction, so this is the line of action where this FA force is acting. Now from the given figure we know that FA and FB both make an angle of 130 degree. So now we require to draw this FB force. So with respect to this line, we can easily draw a 130-degree angle and then plot a FB force with its particular magnitude as well as the direction. So let us plot it from the tip of the force component FA. So this is our force component FB, and as I said, this will make a 130-degree angle. And again in the reverse order, if we join that force FA and FB, or the force component FA and FB with closing side of that triangle, that we can say a given force, or that force is now our resultant. And considering the given angle here, so 100 Newton and FA, that will make a 30-degree angle, and FB and 100 Newton, that will make a 100-degree angle. Now if this is a 180-degree completed, so here the remaining angle would be a 50-degree. Now further we use the sine rule. So using sine rule, we try to solve this example. So taking a force one by one, so here FA, that is the first force component, and with respect to that 100-degree is the angle, so we can write down here sine 100, that equals to second force component, that is FB, divided by sine 30. 30 is a corresponding angle, equal to, we have a resultant value available here, so that is 100 divided by corresponding angle, that is sine 50. Right, now if you solve this equation one by one, so first of all we solve FA and this 100 Newton force, so it will give the value of FA component, so that would be 100 into sine 100 divided by sine 50. So if you sort out this would be 128.56 Newton, and similarly this FB component, that equals to again 100, then sine 30 divide by sine 50. Again you sort out this would give 65.27 Newton. So here we have both the answers available in the question. The question is that find out the components Fa and Fb of this 100 Newton. So if 100 Newton is the resultant of these two forces, so that two forces are 128.56 and 65.27 Newton. So this is all about the example.